Hi students, how are you today?
Fine, thank you.
You sure?
Yes, sir.
Alright, in today's mathematics class, we will be looking at numbers. What will we be looking at?
Numbers.
Great, and I know that you already know a whole lot about numbers. Alright? So it therefore means in our class today, we will just be doing a review of numbers. So it wouldn't be a case whereby I would be teaching you something maybe which you didn't know already, but we will just be reviewing certain facts about numbers so that even as we continue learning mathematics, at least we will know, we will have some of those facts about numbers on our fingertips. All right? So everybody excited to start class today?
Yes, sir.
Great. Well, I am excited also. We will look at the various types of numbers. And I know that if I ask you to call them out, you might start calling them out. What are the different types of numbers? Whole numbers, natural numbers, we have mixed numbers, somebody say even numbers, odd numbers.
Arabic.
Oh, Arabic numbers. Well, interesting. We're going to we're going to looking at some history of numbers. So maybe I can ask you for in your own time when you go on the internet this week. Forget about Facebook. Maybe you can go and look up the history of numbers. All right, and then you will come across the Arabic numbers and the Egyptian way of numbering, the Babylonians way of numbering. Right, you will come across, and then you will be able to trace the origin of even our number system. It is an exciting thing. So if you usually spend an hour on Facebook, well, just spend half hour this week on Facebook and use the other half hour to review numbers. All right? Can somebody do that this week?
Yes, sir.
Okay, you don't sound that sure though. All right, numbers. Let us get into our class for today and get into our studies. The first type of numbers we will look at, one of them which you call, is the set of natural numbers. Natural numbers. What are natural numbers?
Natural numbers are numbers that begins from 1 and goes on.
Natural numbers are numbers which begin from 1 and go on. So let me see if I can get this correct, right? Because I guess you know what a natural number is, so tell me if I'm correct. We have 1, 2, 3, 4, 5, 5.5, 6. Why are you shaking your head? Where did I go wrong?
5.5.
5. So 5.5 is not a natural number?
No, sir.
So 1, 2, 3, 4, 5. I was correct up to there?
Yes, sir.
6, 7, 8. 8 and 3/4.
No, sir.
No? So we can't include fractions.
No,
No, sir.
All right, so correct. Natural numbers, that set of natural numbers is made up of the whole numbers starting at 1. And somebody might want to know what I mean by whole numbers. Are we talking about those numbers which has no fractional part attached to them? So we can count, and there's another name for natural numbers because we use it for counting. We say that yes, they are counting numbers. All right? And the natural numbers is denoted by a particular symbol. What is a symbol? What is a letter that we use to denote natural numbers?
Capital N.
Capital N. So we will say natural numbers is equal to the set of, and then we can list 1, 2, 3, 4, and we can keep going on. Somebody might want to know what those 3 dots mean. Who can say what those 3 dots mean? Which of you want to say what those 3 dots mean? Anyone? Come on, I know you know it. Huh? All right. These 3 dots mean that we can go on and on and on. All right, so it means that you do not stop at 100, nor 1,000, nor 10,000. You can keep going on. So you could, if you want to list the set of natural numbers, you can start listing now. You can fill this board, fill all the walls all over, start on the floor, reach out on the road, and you can still keep writing all the natural numbers. You start writing today, you can continue till tomorrow and write from now until you reach 70. All right, and you could still be writing natural numbers because after each one, there is another one. Okay? So that's what this symbol here is saying to us about natural numbers. Now, the other type of numbers which we will look at is the set of whole numbers. The set of whole numbers. I mentioned before that whole numbers refer to those numbers without any fractional part. And we have these here. Therefore means all of these are whole numbers. Do you agree?
No, sir.
Which of them is not a whole number?
Sir, one is missing. Not
No, but all of these here are whole numbers though.
Yes.
All right? Good. All of these here are included in the set of whole numbers. Good, but then we are hearing that one number is missing. Marina is saying that one number is missing that is not in the set of natural number, but that number is also a whole number. So, Marina, which number is that?
0.
The number 0. How do we denote whole numbers? Which letter do we use? Capital W. Interesting, because we see when it was natural numbers, we use capital N. Whole numbers, we use capital W. So we can list the set of whole numbers as W is equal to the set of 0, 1, 2, 3, 4, 5. And then we can list these 3 dots indicating that you can keep going on and on and on until you reach 70, 80. In age, I'm talking about, keep on writing from now onwards. And you will just keep listing them as that. So we have 2 sets so far. We will observe that all the elements in this set can be found in that set. So, if all the elements in this set can be found in a set of whole numbers, what is the relation between these 2 sets? All the elements of this set can be found in this one here. So what do we call this set is what to this one here?
Subset.
Very good. It is a subset. So we can say that N is a subset of W. This natural numbers form a subset of whole numbers. Is that clear?
Yes, sir.
Is 0 a natural number?
No, sir.
But 0 is a whole number because 0 is 0. It isn't 0.5 or anything. It is just 0, a whole number. Now there is a third set of numbers which we will be looking at. And that third set begins, the letter begins with I.
Integers.
Integers, good. Integers. What are integers? Who's going to say, what are integers? What type of numbers come to mind when you think of integers? What type of numbers come to mind?
Yeah, fractions.
Fraction. Someone is saying fraction. Anyone else?
Sir, negative and positive number.
Harish is saying negative and positive numbers. Anyone else? All right. I wish to add a little to what both of you said because it is negative and positive numbers, correct? But negative and positive of a particular type of numbers. So the type of numbers which is negative and positive that we're dealing with does not include the set of fractions though. Integers refer to the set of negative and positive natural numbers together with another number. Together with the number 0. The number 0. So integers are made up of the set of negative and positive natural numbers together with 0. So if we were to write this, we will say integers will be equal to natural numbers together with union, all right, together with the set 0. So we can say it is positive and the negative natural numbers. This is how we write positive and negative. This set together with 0. The symbol we use for integers is Oh, I thought someone was going to say I. Because for natural numbers, we use N. For whole numbers, we use W. But for integers, as you correctly say, we use Z. Correct. So we can write Z is equal to the set of, we're dealing with negative and positive natural numbers together with 0. So it therefore means you can take negative numbers, you can start listing negative numbers, and you can go up to -4, -3, 2, 1. Then we can have 0, 1, 2, 3, 4. And we can list the set of integers as this here. Is that clear?
Yes.
All the negative and positive natural numbers together with 0. Is 0 negative or positive?
Both.
Both. Actually, 0 is neither. 0 is a special number. 0 is neither negative nor positive. Because actually a number cannot be both negative and positive. Alright? But 0 is treated as a number which is neither negative nor positive. So it therefore means this 0, 0 has no regard for negative and positive sign. Of course, if we wish, we can add in positive sign in front of it here. However, it is understood that if you see any number without the plus sign in front, that it is a positive number. But for it to be negative, you must have this minus sign in front of it. Is that clear?
Yes, sir.
Good. So we have -4, and we go all the way to 0, then +1, +2. This is also +3, +4. But with the positives, we can drop the sign. So we have integers. Can you see the set of whole numbers in this set of integers?
Yes.
Yes.
The set of whole numbers will be 0, 1, 2, 3, 4, and we can keep going on. So it therefore means that whole numbers form a subset of integers. So we can say that whole numbers form a subset of integers. Can you see the natural number set listed here? The set of natural numbers listed here?
Yes, sir.
We have 1, 2, 3, 4, and we can keep going on. So it therefore means we can also say that natural numbers is a subset of integers. And of course, because natural numbers is a subset of whole numbers, and whole numbers is a subset of integers, well then, obviously, natural numbers will be a subset of integers. There is another set, which is called rational. Yes, rational numbers. Now I want somebody to tell me about rational numbers.
Rational numbers are fractions.
Okay, yes, Stanis, continue. Rational numbers are?
Factors.
Rational numbers are fractions. And Tanis is ending at rational numbers are fractions. Anyone else wish to add to that? Rational numbers are fractions. Varsha, you had your hand up. You want to add anything to what Tanis was saying?
No, sir.
No, so you agree that rational numbers are fractions. Is there anyone else who wish to add to rational numbers? All right, well then I will add a little to rational numbers. Rational numbers is made up of the set of integers together with fractions. So it's not just fractions alone, but it also includes all integers. Is that clear? Yes. So it is a set of integers and fractions. And there's a special symbol we use for denoting rational numbers. A letter. Yes, correct, Harish. Harish is saying what? Say it, everyone should hear you.
Capital Q.
Capital Q. So rational number is denoted with the capital Q. Okay? And rational numbers is made up of all integers. So if we can list the subsets of rational numbers, then we can list the subsets of rational numbers as, we can say, integers, and we list the set of integers previously, as we can start with -2, -1, 0, 1, 2. And then we can go on to list all the different types of fractions. We have the proper fractions, the different types of fractions we're going to list now. We can talk about the proper fractions. And the proper fractions, can anyone give an example of proper fractions? 1 upon 2. Another one? A quarter. A fraction without 1 being in the numerator. Anyone else? 2/5. Good, thank you very much. Yes?
3/4.
3/4. Yes, all of those are proper fractions. As long as the numerator is smaller than the denominator, well, then we have a proper fraction. So, for example, we have the 2/3, and we can list all those other examples which you mentioned about just now. Then we have the improper fraction. Give me an example of an improper fraction, class.
3/2.
3 upon 2. Good. Hamer saying 3 upon 2.
6/5.
6 upon 5, improper fraction.
4.
7 upon 4, improper fraction. Anyone else want to give an improper fraction?
4, which we said.
Yes?
8/2.
8 upon 2 as an improper fraction. 8 upon 2, but of course we can break 8 upon 2 down though, right? So one example here we can look at is 6 upon 5, and there are other examples that we can look at. We have 6 upon 5 as an improper fraction. We can have, for example, 21 upon 8 as an improper fraction. But then not only are rational numbers fractions, or can be expressed in fractions, how else can we express rational numbers in terms of what?
Terminated decimal.
Decimals. Yes, we can express rational numbers in terms of decimals. So we can talk about terminating decimals. Terminating decimals. And someone can give an example of terminating decimals? All right, let me give one example. 0.45. That's one example of a terminating decimal. 0.45. Can someone else match me and give me an example now?
0.5.
0.5. Someone else? Another?
0.23.
0.23. Anyone else? One more?
0.34.
0.3,
34.
0.34. Yeah, those are all terminating decimals. When we say terminating decimals, for example, 0.5, when we say terminating decimals, we mean that there is an ending to the decimals. All right? There is an ending. It doesn't keep going on and on and on. If it keeps going on and on and on, what do we call that? Either recurring or non-terminating, right? It terminates or it does not. So we mentioned about the recurring decimal. That is also a rational number. Recurring decimals. Can someone give an example of that?
0.66666.
0.66666. Danica is saying. Someone else?
0.3333.
0.3333. Yes, all of those are recurring decimals. As long as it keeps going on and on like that, we say it's a recurring decimal. So we have, for example, 0.3333, and we can keep going on like that. Recurring decimals. So all of these are rational numbers. All right? All of these are rational numbers. Good. Now, in the set of rational numbers, observe we have integers also. So it therefore means integers form a subset of rational numbers. And whole number was a subset of integers. And natural number was a subset of whole numbers. So it therefore means we can now, given that we have learned so much about sets, we can now set up a Venn diagram to show these four sets of numbers on a Venn diagram. So, each of you, go ahead. Take half a minute to construct a Venn diagram to show rational, integers, whole, and natural numbers. So your Venn diagram will show the relationship among the different sets of numbers. Someone is finished? Okay, maybe I might start with, you can help me. I will start with natural numbers. The set of natural numbers. Well, the set of natural numbers is a subset of the set of whole numbers. So it therefore means this loop of natural numbers must be part of a loop of whole numbers. Do you agree? So it is not a case whereby we have to join them in this manner, because we're talking about one set is a subset, so it must fit entirely into the other set. So then we can have the set of whole numbers in this way, because all natural numbers form the whole numbers, are part of the whole number set. And whole numbers are part of the integers. All whole numbers are integers. So again, we now must have the integer loop. Alright? So anybody looking here will see natural numbers is a subset of whole numbers is a subset of integers. And all integers are rational numbers. And this is what our diagram should be looking like. If we will show the relationship of Venn diagram, to show the relationship among the sets of numbers. We will now go on to look specifically at this larger set of number, the rational numbers. And we're going to look at ordering rational numbers, how we order rational numbers. There are two ways in which you can order numbers. One is when you order from the smallest to the largest, and the other is when you order from largest to the smallest. And there are particular names we have for when you're ordering from the smallest to the largest. Yes, Akisha?
Ascending and descending.
Which one is ascending?
From the largest to the smallest.
Ascending is like when you're going up, so you're going from the smallest to the largest. And descending is when we're ordering from the largest to the smallest. So we will look at ordering rational numbers, or we will look at ordering them from those two ways, either ascending or descending. Ordering rational numbers, and we can order rational numbers either in ascending, or we can order them in descending order. Either one of the two ways we can order the rational numbers, either in ascending or in descending order. And ascending, we discussed, is that it is from smallest to largest, and descending is from largest to smallest. Let us take an example. Consider these numbers. Yeah, we have these 5 numbers. To write them in descending order. So in descending order, which will be the first number? The largest or the smallest?
Largest.
Yes, because we started with the largest and we're going down. For us to order numbers in ascending or descending order, especially if it is fractions like this here, well then we need to establish what is the lowest common denominator or the lowest common multiple of the denominators. Okay, so we examine our denominators. We have 6, 8, 24, 12, 48. We're looking for the smallest number for which all of them can go into, for which all of them can divide. Which is that number? 48. We all agree 48?
Yes.
Good. So we agree that 48 is the smallest number of which all of these can go into. So just as when you're adding fractions, we can then perform the same operation. We know 48 is the lowest common denominator, so we divide and then multiply as we would normally do if you're going to add. The only thing we're not adding, we're going to separate them with commas. So we go 6 into 48, and then 8 by 1 is 8. Then we have 8 into 48, 6, 6 fives, 30, correct. 24 into 48, 13 twos, 26, 12 into 48, 4 sevens, 28, 48 into 48, and 1 by 5 is 5. So what we do next, we can then rewrite these numbers in terms of the denominator 48. So what we have here is 8 over 48. Then we have 30 upon 48. 26 upon 48. 28 upon 48. And 5 upon 48. So we rewrite all of these here now as that number divided by 48. And we now, since all the denominators are the same, we can then look at the numerator to see which numerator is the largest. And whichever numerator is the largest, that represents the largest fraction. So, which numerator is the largest? 30. So it therefore means 30 upon 48 is bigger than all of these. But which of these fractions 30 upon 48 correspond to? 5 eighths. So we start with 5 eighths. 5 eighths. Which one is next in order? 7 upon 12, because we have the 28 upon 48, which corresponds to 7 upon 12. Yeah, finish it off in a couple seconds. Good, I guess you're finished. So which is the next number? Which of these? 13 over 24, followed by?
6.
Followed by?
5 over 48.
The last number, 5 upon 48. Now remember, if a question asks you to list these numbers here in ascending order, these numbers, well then you cannot write this set here in ascending order and say that that is your answer. Because the question didn't ask you to write this set of numbers here. These are equivalent fractions to these, but the question specifically gives you this set here. So you must write this set in the descending order as was given here. Good. Let us consider an example, another example. But this time we're going to look at some decimal numbers. Do you like decimals more than fractions? No, you prefer fractions?
Yes.
Oh, we have a division in the class. Some persons prefer decimals, while some prefer fractions. But as mathematicians, we're supposed to love both of them, because we have to master both fractions and decimals. Do you agree? If we're going to be the next set of mathematicians in Guyana? Harish?
Yes.
We have to master both of them. So take these numbers. And we're going to write these numbers in ascending order. So we want to write them from the smallest to the largest. Just as with fractions, we need to identify our denominator, that common denominator. Unlike fractions, though, we cannot see a denominator here or a numerator. It is all written in one straight line. However, what we look for is the number of decimal places. Which number here has the largest number of decimal places? And whichever one has the largest number of decimal places, we write all the other numbers with the same number of decimal places. So what is the largest number of decimal places we have here?
0.138.
All right, we have 3. This is 2 decimal places, 3, 2, 2, 3. So the largest is 3 decimal places. So let us rewrite each of them with 3 decimal places. So we have 5.060. We add in this third one with a 0. It doesn't change the value of the number. Then we have 0.138. Then we have 0.250. See how we're making it from 2 decimal place to 3 decimal place? By just adding a 0 to the end. 1.330, 0.009. With this now in place, it makes it easy for us to tell which is the largest and which is the smallest number. Because all we do is just imagine there was no decimal place there. What will the number be?
5.
If there was no decimal place, well then this is 5,060. This is 138, 250, 1,330, and this is 9. And remember, we're listing them in ascending order. So in ascending order from the smallest to the largest. So which is the first number? Which is the smallest?
9.
So we list in ascending order. We have 0.009, our first one. Which is the next smallest?
0.35.
This is like 250. This is like 138. So which one is smaller?
0.138.
Followed by?
0.250.
But we stop with 0.25 because remember, the numbers which we have to order is this set of numbers. We just modify it to look like this. When we're going to list them in order, we're taking from this set here. Followed by?
1.33.
1.33. And then we have
5.06.
5.06. And that is how we order numbers. So if it is fractions, we use the lowest common denominator. If it is decimals, well then we write all of them to the same number of decimal places, and then just imagine the number had no decimal point, and just read it as what it looked like. 5,060, 138, 250, 133, 1,330, 0.009, and that makes it very easy for us to identify which is smallest to which is largest. Are there any questions? You sure?
Yes, sir.
Good. So let us just recap what we did in today's lesson. We looked at the different types of numbers. Those different types of numbers are natural, whole, integers, rational. We identify that they are subsets of each other. Natural numbers, subset of whole numbers, whole numbers, subset of integers, integers, subset of rational numbers. Rational numbers also include the fractions. We have the proper fractions,
Improper.
improper fractions, all of those are rational numbers. In terms of decimals, we can talk about the terminating decimals, the recurring decimals, good, correct. And then lastly, we looked at ordering of rational numbers, how we order rational numbers if they are written as fractions or if they're written as decimals here. Good. I look forward to our next class when we meet again, and I hope you will be here again to let us continue to have some fun with mathematics. Good. Bye then.
Bye, sir.